Hello, I'm Rob Hirschfeld, CEO and co-founder of RackN, and this is a Digital Rebar training led by our co-founder and CTO, Greg Althaus. He presents a whole bunch of material. In this section, he is talking specifically about pooling and how to use the pooling system.
We'll start with the pooling architecture. So these are in the docs. I'll put these links into the chat so that you guys can have them as well. The idea behind pooling is to allow you to group machines. And that is a loose grouping. There's no real meaning behind it other than there's a field on the machine object that defines what pool something is in. It also allows for tracking kind of usage within that grouping. And so what we mean by that is you can put a machine into a pool and it will sit there in a free state. You can then allocate or reserve or whatever term you want. We tend to use in the API, allocate a machine in that pool. And it stays in the pool, but it transitions from a free state to an allocated state or an in-use state. And then that machine is no longer eligible to be consumed from that pool. It just sits there as a element in it, but it's not usable. Then when you're done with use, you can release that machine and it will move back to the free state within the pool. So that's kind of how you can track the things within a pool, whether they're used or not. And then on top of that, the pooling system allows you to define actions that you want to take to the machine as it transitions through those states, okay? So what that means is by default, if I add a machine to a pool or I allocate or I release or I remove a machine from a pool, nothing will happen. It'll just move among the pools. But I can define either upon the API call to take that action or create a pool object that defines the actions, things like add this workflow, set these profiles, remove these parameters on each of those transitions, okay? As always, ask me questions or interrupt if you have concerns or thoughts, okay?
Quick question, just kind of thinking through the architecture. I am kind of going on the assumption that the pool is a kind of one-to-one relationship with the machine. Like one machine can only be in one pool, correct?
Correct.
Okay.
Yeah. As we're about to get to that part next.
Okay.
So pools are dynamic and exist because a machine is in the pool. So I can say I put a machine into the baseball pool and the baseball pool then exists because there's a machine in it, okay? If you're familiar with RackN's DRP, you'll understand that there's objects, right? We have objects for our API, so you have a machine object. A pool exists independent of its pool object, okay? Basically, because a machine has that value in its pool field, that pool exists for you to operate against, okay? Now, it may not have any default actions because you don't have a pool object associated with it. So that's what we mean. The pool is kind of this ephemeral concept that lets you mix and match and put things together. But if you really want to define additional actions, we can define a pool object, okay? But that leads to, like, I guess that was, I'm not sure who that was, I didn't see. The machine can only be in one pool. Okay, pools can be hierarchical. So you can say if you create a pool object, then you can say like baseball is one pool, and then I can create another pool, which is Fenway Park, right? and Fenway Park is a child of baseball. And so if I like remove machines from Fenway Park, they will go into the baseball pool. And then if I remove them from baseball pool, they'll go into the default pool. By default, the system has one pool, and in 4.6, the system will have two pools that exist by default. One is the default pool. This is the pool that all machines go into just because. Then there's a new pool in 4.6 and beyond called the self-runners. And this is a pool that collects all of the machine objects that represent the DRP endpoint itself. In 4.6, we're embracing the idea that you could manage the DRP endpoint with as a machine object with workflows and other things to run against itself. And that has a machine object that represents it. Those go into a separate pool to keep them from being accidentally allocated and stuff like that. Okay, makes sense? The other thing to realize about the pool system is it has its own API. So because the pool objects are independent, the actual actions to add and remove machines from the pool are done through the pool API. And those operations can be made blocking and non-blocking with timeouts based upon how you choose to call the API. Okay, and we'll talk about more of that in a second under operations. Okay, so like we said, the functions are grouping. I mentioned already in the default pool, and there you can, the pool API is the first pooling or first RackN API that allows you to do things against multiple objects. So you can give the pooling API filters, much like the in the UX, you can filter machines by parameters and other conditions. The same applies to the API, and you can give that same kind of filtering to the pool API, and it will let you do actions in bulk against that set of machines. Now in the covers, it turns it into singleton atomic operations against each machine, but the API itself is letting you do batch kind of commands. You, like I said, you can add and remove them from the pool and then allocate and release. Let's see. That's allocation and then transitions. Like I said, you can think of the pools as little mini state machines where each machine has its own little state that it's in while it's in the pool, and we'll talk about that a little more here in a second. But upon those transitions, the pools can define actions, and we'll talk about that a little more. Okay, actual implementation. On a machine object, you will see three pool associated fields. One is pool, which indicates the pool the machine is in. So you can kind of filter just by querying what pool a machine is in. You can get its status. That's the state it's in, and we'll talk about that a little bit below. And then there's whether it's allocated. And the allocated is just an extra Boolean field to help filter without having to know that it's in use, right? Allocated is true when the pool status is in use. So it's a kind of a helper visualization thing, okay? The pool system relies on the workflow complete field of the machine to indicate that a workflow is complete. So the pool won't move machines around that aren't in the workflow complete state. So the idea is that if you're running a workflow, the machine is in some kind of transition. Once that workflow completes, then you can move it among pools, which we'll have to think about how this is actually going to work. It's interesting. Well, we'll see. That alone might make some of this interesting. Still doable, but okay. Pool status. So like I said, there's a concept of a state machine for the machines as they go in. When a machine joins a pool, basically when it goes into the pool for the first time, it enters the joining state and will be running workflows defined for entering the pool. If there's an error that occurs during that workflow, the status will go to hold, indicating that it couldn't be completed to join that that pool, and will sit there waiting for operator intervention to clear the error and let the workflow complete so that it can then get to the free state. Once it's in free, it's available for allocation. So once the machine gets allocated through an API call, it'll go into the building state where it will run through a workflow potentially to do allocation work. And if there's a failure in that, it will go to the hold build state for it to be resolved. Once that's complete, then it'll go to the in-use state. You'll see kind of a trend here. When it goes from in-use and gets released from allocation, then it will go into a destroying state. Again, a failure will indicate hold destroy. You can kind of see a pattern. And that'll go back into the free state. And so as long as a machine is assigned to a pool and you're wanting to just bounce it back and forth between in use and not in use, then it'll sit there going back and forth between the free and in use state. Then if you remove the machine from the pool and either put it back into the default pool, then it technically can go through a leaving workflow, and that can then, if that fails, it'll go to a hold leave. Now, if there are no workflows run as part of the transition, those steps are basically skipped and they just go direct to their next states. Okay, questions on that? So in your use case, you had mentioned like what you want to do is be able to have machines classified upon initial discovery into pools. Then at some time later, when you decide that machine needs to do something, you want to allocate it to a specific use. That allocation would define a workflow that it wants to do as part of that allocation, and then it would go into in use. And then you wanted to decommission something or wipe the system back to a known state upon deallocation or releasing the machine. You would then set that workflow as part of the deallocation, and it would go through that workflow, and when it was finished, it would go to the free state. That's the intent of that kind of flow. Okay. Make sense?
Yeah. Yes.
Okay. So the last part is the pool object itself. If the pool object doesn't exist, the transitions just happen automatically, with the exception that you can always force them on to the API calls. But the idea is that a pool object allows you to define basically entry actions, exit actions, allocate and release actions. And that allows you to do things like set a workflow, add or remove profiles, add or remove parameters, okay? If you actually were to look at the object in Go, you would see that there's even some future work to do auto-filling of pools. That part hasn't been fully implemented yet. It's a placeholder, okay? Now, from an operations perspective, all of these are provided through the DRP CLI. And in this document, we actually show you the calls that you can do that are equivalent through the API. So if you're used to just doing your direct API calls. So if you can list the pool objects, right? And these are for the objects themselves. So you can list, you can show, update, destroy, much like you can through the normal CLI. And then that's also with the similar API calls for this setup, okay? Now, this set of calls are limited to the pool objects themselves. If you want to see what the active pools are, you can do pools active. And active is kind of like list, but will also show you the ephemeral pools in the system. So like here, if I do DRP CLI pools list, I have no pools defined in the system. But if I do pools active, you'll actually see I have default and self-runners because I have machines sitting in those states, right? So I have these sets of machines, making sure they all finished. Yeah, okay. And I have my self-runner machine, which is representing my DRP endpoint. And then I have, in this case, 20 machines that I'm playing with, and they're all in the default pool, okay? Now, I can also get the status of a specific pool. So in this case, it's similar to like a machine view, but I get the freed objects, right? I get a list of free objects. I could get a list of in-use objects, that kind of stuff, okay? And then I have the actual actions to add and remove machines from the pool. And you'll notice there's a lot of additional parameters that allow me to define what I want to do. So I can say, hey, if I add a machine to the pool, add a parameter to that machine, and I can give it a key value like pair to add a parameter to the machine, or I can add a comma separated list of profiles to add to the machine as I move it through the system, okay? I can have machine selectors where I can say like from all machines, select a count of 3, and that will move 3 machines quasi-randomly from the pool into it or allocate those or whatever. I can also machine list, which is basically a filter, much like we build up in the UX where you can say like filter machines that have CPU of 3 or right, that kind of stuff. And we'll show you some of these in a minute, okay? Minimum, so you can actually say I want 12, but make sure I get at least 3, and the commands will return partial success, right? If it can get 3, it'll return that it got 3, which 3, and then it indicates the others, okay? And then you can even pull things from other pools. This is for the add operation. So you can say from what pool do I want to pull into this pool? The default is default. Okay. Let's see. So the CLI is providing help for these commands. And like I said, I also gave you the API endpoint target. So like if you post to this location, but you'll need data. And the actual data structure is defined like that. So if you post that JSON blob, that kind of shows you how you can fill in these appropriate parameters from that system, okay? So that's part of it. And then we actually have the definition of the pool object where you can then kind of hopefully see what we're doing, where you can define your interactions, and then all of these fields are optional. So if you don't specify them, they are ignored, but you can define the workflow to change as you enter and when you exit, okay? Questions so far?
Not right now.
Okay. So in this case, what have I got to play with this a little bit? And then we'll start building some of this stuff. I have a DRP instance. I have it running some containers. So I'm using our context system to define some containers of machines. And I wrote a little script so I can recreate them so that they can run through. So I can get a variable number of CPUs in memory and kind of have a fake system to play with. So I can rebuild them and iterate for testing and development purposes. So in this case, I just kind of deleted them all and they all disappeared. So in this case, I spin this back up. And so now they'll sit there and kind of run through their system. And I can then get them listed. Okay. So of course my system gets a little tired, but it's fine. Okay. So there's my system. I can filter by pool. So in this case, notice Freddie isn't in there. I can pools. Let's see. Back over here and make sure I don't mess up. All right. Pools, manage. So there's a subset of commands. I can say add, and then I'll say all, I'll just say count equals 5. And I'll name it demo 1. So in this case, it grabbed 5 machines somewhat arbitrarily and put them into demo 1. So if I do active, I can see now that I have 3 pools. If I status demo 1, I can do that. I can then, like I said, allocate, and I could say all the machines. And in this case, they all are allocated immediately and transitioned in use. If I say I wanted to add 8 machines to demo 2, oh, I have 20 machines. So I didn't do a big enough pool. So that pulled 8. And now if I say 18 machines to demo 3, I'll get a failure indicating I couldn't get 18 machines. Minimum of 3. In this case, I can see that I got 3. Well, I got at least 3. So in this case, I got back 7 because there were 7 remaining. And so it met the conditions of at least 3, but no more than 18, okay, in my demo pool. So then if I status demo 3, see them, right? And then I can just remove them all, okay? We'll put them back in demo for the time being. Oops. Oh, I guess they're already back. Or maybe it's not demo, it's one that's demo. Okay, what did I name it? Oh, okay, that's a good thing to note. The pools have protections. So if a machine is in use, you can't remove it from the pool. You have to release it before it can be removed from the pool. So in this case, I said remove all the machines from demo 1. It said I couldn't find any to remove. Okay. So now if I release all machines, now I can remove them. Now, if for any reason the systems get stuck or you feel like they're just wrong, there is the force flag, which will allow you to bypass those validations. So if you add -force, it will actually force it out of the pool or out of its state into the other if you feel like it is incorrect. But use that if you are sure of what you're doing.
Thank you for listening to our training session. I hope it was helpful. As always, we want to hear from you. Please join our Slack community, ask questions, let us know what additional things you want to hear training on, and we are happy to make sure that you get educated about Digital Rebar. Thanks.